Hi everybody, today is my first video, so please be patient and be tolerant because it's the first time I'm trying to do this with my iPhone. So today I would like to show you how we can break the 1 microamps consumption power with a basic Arduino Mini with a LoRa node shield and an SI7021 temperature and humidity sensor. Of course, the board is also provided with a LoRaWAN Lora chip, which is RFM 95. So you have here the basic to create a basic node to send data to any LoRaWAN application. In this case, we use the LoRaWAN server Duffing Networks, which is pretty cool and pretty free. So it's really a cool product and cool application. I use it every day on my job. So I already published all the information to build this little node, and I know a lot of people have built it. Today I would like to show you how we can achieve a lowest consumption possible. So what I've done to do this goal is to remove the regulator on the Arduino Mini. As you can see, there is here, let me take something to show you. There is here a little footprint for the regulator, and the regulator has been removed. Okay, so because regulator is not used, and I don't want question current to override some protection and to override some current not needed. I also do the same thing on the sensor here with the eBay sensor SI7021. I don't know if I think it's cool. And what I've done to this sensor is the same thing. I removed the regulator on the back side and put a 0 ohm resistor. In this case, there is no more regulator on this device. These devices are provided with regulator to be compatible with Arduino in 5 volts alimentation, but in this case we don't use it. So I will plug back the sensor. So here the power I use is 3.3 volt. The multimeter is to measure current. For now it's set to milliamps because when the board is starting and it's sending this first frame, it will consume a lot, and if I put it to microamps, it will override it will activate the protection of the voltmeter, so it will not work. So maybe it's time to start the device. So push on here. As you can see, the LED is blinking because the node is doing a join on the network server. So it takes some time. I think we will see it appear on the Thing network soon. Of course, when I'm taking the video, it will be longer than ever. But the Murphy's law. Let's set the device to connect to the Thing networks. Maybe it can be quite long, so maybe you can forward the video if you want. Last time I did a test, it took almost 5 seconds, but okay. So sometime I need to restart it. Maybe it will work better. Okay. Okay, that's it. I got it. You know, it's not blue because it's okay. The device has joined the network and sending a packet. That's done. The device, as you can see on the voltmeter, there is 0 because the device is not in sleep mode. So we have on TTN the joined request and also the first data. So as you can see, temperature here. I don't know if if you can read it on my phone, and humidity. I have some other value, and here battery voltage 3.3 volts. Okay, so as for now the device is working with the watchdog enabled. So the watchdog of the Arduino Mini is waking up the device every 8 seconds, and we send the data every 5 minutes. So every 8 seconds the watchdog is wake up, doing nothing until you need to send data. So in this configuration, let's see how do we consume. So I take the voltmeter to microamps, and as you can see, The consumption in sleep mode is 5 microamps. Well, it's not what I expected, but the watchdog is activated, so I think it do some consumption power on the Arduino. So I made a cheat on the program to disable the watchdog and to be able to wake the device with a push button that is located under here. So what will I do is to configure the device back to no watchdog wake. So the device will not wake anymore until we press the button. So I switch back to my dance because it will consume some current, and then I push the button for 3 seconds. 1, 2, 3. Okay, that's it. The device send back a new data, but I'm not really sure. Maybe I press the button. I don't know how the code is written. I need to check back, but maybe, yeah, it's always 5 microamps. I press the button too long because each second it adds a new function, so I will try again. Sorry about that. So 1, 2. Okay, that's it. As you can see, there's a new frame coming. Okay, so I think now we're done. Let's switch to microamps. Yeah, the device is consuming 1 microamps with a little Arduino Mini and some sensors. So you have a Lora node, 1 microamps consumption for less fun than 20 bucks. So it's, I'm quite happy. I know the drawback is that the node is never waken except if I press the button, of course. But never mind, it's just to show you how low we can consume current. So the strategy to remove the watchdog from the Arduino Mini is a good one. So I'm creating some board with a new chip which is TPL 5110, which is made to send a pulse to the Arduino Mini from 1 second to 2 hours. So, and this device consuming only 35 nanoamps. So this device could wake the Arduino Mini instead of enabling the watchdog on the Arduino Mini. So we can have a board with 1 microamps consumption in sending data to LoRaWAN networks. So it's I'm really happy with that results. So thank you for seeing this video, and maybe get in touch to see another one. Bye bye.